Namaskaram everyone. Good morning and welcome to another day of webinars. Dear students, I welcome you all for the TSMS webinars of today. To begin with, we have mathematics session that is from 1B. Students, you have learned about straight lines in your earlier sessions, right? That was about equation of a straight line. That means single straight line in various forms. To take it further, we will be learning about pair of straight lines today. And to present the topic, we have with us the dedicated and compassionate, very passionate about his teaching, Mr. K. SRINIVAS, PGT from TSMS Ambam, that is Barni Mandal and Nizamabad district. Sir has taken all the effort, he has put in all the efforts to make it very interesting and informative for you. And sir will be teaching you about pair of straight lines today. Srinivas sir, welcome and over to you.
Good morning, madam. Thank you, madam. Good morning, all. This is Srinivas, PGT Maths, TSMS Ambam Varni Nizamabad. First of all, I am very thankful to Assistant Director Sir, Joint Director Sir, and entire webinar team for giving this opportunity to share my views to the students and teachers through this webinar session. Good morning, students. In the previous sessions, we have discussed about the properties of straight lines, that is different types of straight lines, point of intersection of two straight lines, angle between two straight lines, length of the perpendicular from one point to one straight line, and I think that you have all are familiar with all these concepts. Today we are going to discuss a new chapter, that is pair of straight lines. In the paper 1B, pair of straight lines is there. So its weightage in the examination is 14 marks. That is 2 7 marks question will be obtained. So here we are going to discuss about that pair of straight lines. Such as that in this pair of straight lines, we will discuss today as such as combined equation of two straight lines and second degree homogeneous equation, second degree general equation in the variables of x and y, and angle between two straight lines or angle between pair of straight lines. So in this chapter, pair of straight lines, we will discuss about that combined equation of two straight lines, second degree general equation, equation of pair of straight lines passing through the origin, angle between the pair of straight lines.
Srinivas sir,
Madam.
could you please go for slideshow?
Okay. Okay, madam. Thank you, madam. In this chapter, we will discuss about that combined equation of two straight lines, second degree general equation, equation of pair of straight lines passing through the origin, angle between the pair of straight lines, condition of pair of straight lines to be perpendicular, and angular bisectors, equation of pair of straight lines, that is equation of angular bisectors of two straight lines, conditions for pair of parallel lines, and distance between them, point of intersection of pair of straight lines. At last, we will discuss about that homogenizing a second degree general equation with a linear equation. First of all, we have already discussed the properties of straight lines in the previous chapter. So all of you know that the equation of the straight line is in the standard form of that ax plus by plus c equal to 0, which is not passing through the origin. So now the equation of the straight line which is passing through the origin is of the form of y equal to mx, or mx plus y equal to 0, or mx minus y equal to 0. So in this case, only x and y terms will be there. So in this case, let us take any two straight lines, 2x plus 3y equal to 0 and 3x plus 5y equal to 0. Let us multiply both the equations. Multiplying above two equations, we'll have that 2x plus 3y into 3x plus 5y equal to 0. After simplification, we will have that 6x square plus 10xy plus 9xy plus 15y square equal to 0. Again, so we will have that 6x square plus 19xy plus 15y square equal to 0. Now, above equation represents a combined equation of the given two straight lines, 2x plus 3y equal to 0 and 3x plus 5y equal to 0. So we will get that after multiplying both the equations of two straight lines, we will have the combined equation of those two straight lines. So here, the after multiplication, that equation 6x square plus 19xy plus 15y square equal to 0, that equation is of the form of ax square plus 2hx square plus by square equal to 0. So in this equation, we will have the terms of x square term and xy term and y square terms will be there. So therefore, after simplification, we will have the equation of the form of ax square plus 2hx square plus by square equal to 0. Now we are going to discuss about that. What is that combined equation of given two straight lines? So let us take any two straight lines. Consider two straight lines. L1 equals to a1x plus b1y equal to 0, where modulus of a1 plus modulus of b1 must not be equal to 0. Similarly, L2 equal to a2x plus b2y equal to 0. Here also modulus of a2 plus b2, modulus of b2 is not equal to 0. Both the terms should not be equal to 0. Then after multiplication, these two equations, L1 into L2 equal to, now we are going to write the combined equation of these two straight lines. That is a1x plus b1y into a2x plus b2y equal to 0. So in this case, we will have that a1x into a2x. We will have that a1 a2x square, and a1x into b2y, that equals to a1 b2 xy. Again, b1y into a2x, that is b1 a2 xy or a2 b1 xy. Again, b1y into b2y, that equals to b1 b2 y square. So this equation is called the combined equation of given two straight lines, L1 equal to 0 and L2 equal to 0. Now it is also in the form of ax square plus 2hx square plus by square equal to 0. Now comparing that equation, already we have multiplied that. After multiplying that L1 into L2, we will get the equation, that is a1 a2 x square plus a1 b2 plus a2 b1 into xy plus b1 b2 y square equal to 0. Now comparing this equation with that ax square plus 2hx square plus by square equal to 0, here we will compare the terms, coefficients of the terms x square and xy and y square from the both the equations. That is a1 a2 equals to a1 a2 equals to a, and a1 b2 plus a2 b1 equal to 2h, and b1 b2 equals to b. So here above equation is a second degree homogeneous equation. So here, by observing that above equation, for all these terms, they have the degree of the 2 only. Here, x square. What is the power of that x here? 2 is there. Again, the degree of this term, x term is what is that? X to power of y into y to power of 1 means what? Here also we will get the 2 degree as this term is 2. Again, here the degree of that y square also 2. So therefore, all the terms having the same degree. Therefore, this equation is known as the homogeneous equation. That is second degree homogeneous equation. So now this second degree homogeneous equation, that is ax square plus 2x square plus by square equal to 0, that is denoted by the letter h equal to 0. Therefore, we will call it as h equals to ax square plus 2x square plus by square equal to 0. Now, let us discuss about that second degree general equation. Now, up to now, we have discussed about the second degree homogeneous equation. Now, we are going to discuss about that second degree general equation. Now, here also, we have to take two more straight lines, which are not passing through the origin. So, therefore, let us take that L1 equal to A1x plus B1y plus C1 equal to 0 and L2 equal to A2x plus B2y plus C2 equal to 0 be any two straight lines. Then multiplying these two equations, L1 into L2 equals to A2x plus A1x plus B1y plus C1 into A2x plus B2y plus C2 equals to 0. After multiplication, we will have that A1x into A2x, A1 A2 x square. Next A1x into B2y, A1 B2 xy. Next A1x into C2. We will get that A1 C2 x. Again that B1y into A2x, that is B1 A2 xy, that is A2 B1 xy. So by writing all these terms, we will have the terms are A1 A2 x square plus A1 B2 plus A2 B1 xy plus B1 B2 y square plus A1 C2 plus A2 C1 x and that B1 C2 plus B2 C1 y plus C1 C2 equal to 0. In this equation, we will get the terms x square term, xy term, y square term, x term, y term and constant. So this above equation can be expressed as in the form of that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Where in above equation, we will have that x square term, xy term, y square term, x term, y term and constant terms all there. That's why above equation can be represented or expressed as that ax square plus 2hx square by by square plus 2gx plus 2fy plus c equal to 0. So in this case, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This equation can be denoted as s is identical equals to 0. S equals to 0. Here that s equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is called a second degree general equation in that variables of x and y. Let us discuss about one theorem. So, if a and b and h are not all 0, then the equation h equals to ax square plus 2hx square plus by square equal to 0 represents a pair of straight lines passing through the origin if and only if h square greater than or equals to ab. So, it is also an important theorem. So therefore, let us prove this theorem. Here, now we have to prove this theorem in two cases. That is, if and only if means what? By taking the hypothesis, we have to prove the result. Again, taking that h square greater than or equals to ab, taking that h square greater than or equal to ab, and we have to prove the theorem. That is, ax square plus 2hx square plus by square equal to 0 represents the pair of straight lines which is passing to the origin. So here, given that h equals to ax square plus 2hx square plus by square equal to 0, let us take that equation represents the pair of straight lines which is passing through the origin. Let us take that the pair of straight lines which are passing through the origin. Let us take two equations pair of For this pair of straight lines, we are taking the two individual straight lines. They may passing through the origin or may not passing through the origin. I am taking those two equations as L1x plus M1y plus N1 equal to 0 and L2x plus M2y plus N2 equal to 0. Now, so writing the combined equation of those two straight lines, that is h equals, and we have to equate to that h equal to 0. So therefore h equals to L1x plus M1y plus N1 into L2x plus M2y plus N2 equal to 0. Here already we have taken that equation ax square plus 2x square plus by square equal to 0 is passing to the origin, means that is 0 comma 0 is the point on the locus of that ax square plus 2x square plus by square equal to 0. It follows that 0 comma 0, that is origin is a point on the line given two lines, that is L1x plus M1y plus N1 equal to 0 or L2x plus M2y plus N2 equal to 0. Hence, in this case, N1 equal to 0 or N2 equal to 0 means, so 0 comma 0 origin lies on the given two straight lines, that lies on the first line as well as that second line. So here, so if the origin lies on the first line, N1 may be equal to 0. If the origin or 0 0 lies on the second line, N2 may be equal to 0. Then here 2x square plus 2x square plus by square equals to L1x plus M1y into L2x plus M2y plus N2. We will have that L1x into L2x, L1 L2x square, L1x into M2y, L1 M2xy, and M1y into L2x, that is L2 M1xy. So after simplification, plus M1 M2 y square plus L1 N2x plus M1 M2 y. Here comparing the above equation with that ax square plus 2x square plus by square equal to 0 is with the equation L1 L2 equals to A and L1 M2 plus L2 M1 equals to 2H, M1 M2 equals to B, M1 M2 equals to B, and that remaining terms L1 N2 equal to 0 and M1 N2 also 0. So in this left hand side, we don't have the terms X term and Y terms. So that's why these two terms will be 0. L1 N2 and M1 N2 must be equals to 0. So in this case, we have taken that L1x plus M1y equal to 0. That is, so in this case, L1 and M1 must not be equal to 0. So in this case, we will get that N2 equal to 0. Already we have taken that N1 equal to 0. Here we will get that N2 equal to 0. Therefore, that ax square plus 2hx square plus by square equal to 0 represents the combined equation of pair of straight lines passing to the origin. So therefore, here that equation, pair of straight lines equation can be written as L1x plus M1y into L2x plus M2y. So in this case, we got that N1 equal to 0 and N2 also 0. Again, rewriting the equation, that is ax square plus 2hx square plus by square equal to L1x plus M1y into L2x plus M2y. So therefore, here comparing the terms, L1 L2 equals to A and that L1 M2 plus L2 M1 equals to 2H, M1 M2 equals to B. Hence, let us find that H square minus AB value. So we got, after comparing on both sides, we will have that L1 L2 equals to A, L1 M2 equals to L1 M2 plus L2 M1 equals to 2H and M1 M2 equals to B. So let us find the value of H square minus AB, H square. So from this one, L1 M2 plus L2 M1 by 2 equal to H. So therefore H square. So this part is H square minus AB, A equal to L1 L2 and B equals to M1 M2, AB. So now writing that here, in this case, now squaring the numerator and denominator separately, that is L1 M2 plus L2 M1 whole square, and the 2 square is 4. So therefore, L1 M2 plus L2 M1 whole square by 4 minus L1 L2 M1 M2. So in this case, after simplification, 4 is the LCM. So that is L1 M2 plus L2 M1 whole square minus 4 L1 L2 M1 M2. So after simplification, the numerator will be of the form of L1 L1 M2. So it is the A plus B whole square minus 4AB. We know that A plus B whole square minus 4AB equal to A minus B whole square by 4. Here A minus B whole square by 4 means what? So we can write that L1 M2 minus L2 M1 by 2 whole square. So in this case, we got that H square minus AB. So that is a H square minus AB value. So here square of any number must not be negative number. It may be 0 or greater than 0. So therefore we got that S square minus AB greater than equal to 0. Or by getting that S square minus AB greater than equal to 0, so we will get that H square greater than equals to AB. Now we have proved that by taking that equation ax square plus 2hx square plus by square equal to 0, which pass through the origin. So now we will get that H square greater than equals to AB. Now conversely, we are taking that by taking that H square greater than equal to AB. Now we have to prove that the equation represents the pair of straight lines which is passing to the origin. Now we are going to take the converse part. So that is conversely, we are taking that H square greater than equals to AB. So in this H square greater than converse part, we will have the two cases. First one is A. So A is not equal to 0. Second case is A equal to 0. By taking that first case, A is not equal to 0. Now, so here by take A is not equal to 0 means what? Non-zero number. A is non-zero number. Now this ax square plus 2hx square plus by square can be written as. So in this case, I am multiplying and dividing the equation with that A. So first of all, I am dividing by A and multiplying all the terms with that A. That is A into A square, and 2 into A into hxy means that is 2A hxy, that is ABY square. So is there. So in this case, we will have that in the right hand side 1 by A into A square x square plus 2AH xy plus AB y square. So again this can be written as rewriting the terms 1 by A into AX whole square. In this case, A square x square can be written as AX whole square 2AH xy. Now just arranging the terms, setting the terms, that is 2 into AX. AX is as one term and HY as second term. 2AX HY again. So in this case, by just comparing these two terms in the expansion of a by b whole square, a square plus 2ab. In this place, ax is in place of a and hy is in place of b. So here in this expansion, we don't have the b square term. Now we are adding that b square term, that is hy whole square, adding and subtracting to this expansion, that is hy whole square and minus hy whole square. Again, writing that aby square as it is at that last. So here, so after simplifying that, so from the expansion of first three terms, that is ax whole square plus 2axx hy plus hy whole square. So these three are of the form of a square plus 2ab plus b square, which is nothing but a plus b whole square. So here from these three terms, I am writing that ax plus hy whole square. Now from the last two terms, I am taking that minus as common, minus of hy whole square. After taking that minus, I am taking that y square also. So that is minus y square taking as common. So we will have that h square minus ab, h square minus ab. So we will have that 1 by a into ax plus hy whole square minus h square minus ab into y square. So in this case, now again rewriting the terms. So here already we have that is 1 by a into ax plus hy whole square. Now, so just see here, we are writing that h square minus ab y square. So here we can write that this h square minus ab, this h square minus ab can be written as root h square minus ab whole square. We can write that x equals to root x whole square. I am writing this h square minus ab as root h square minus ab whole square. So here we will write this equation as, that is ax plus hy whole square minus y into, already y square term is there, na? So here y into under root of h square minus ab whole square here. So for all these terms, I am putting the bracket and we are doing that square. So in this case, that above equation, above terms are in the form of, so that is, suppose this is a square part and this is b square part. So already we have that formulas, that is expansion of a square minus b square can be stated as a plus b into a minus b. So this term is a and this y into root of a square minus ab as b term. So this is a square minus b square can be written as a plus b into a minus b. So now we are splitting the equation into the form of, that is ax plus hy plus y into 100 of h square minus ab. Again, now we are writing that a minus b term, that is a equal to ax plus hy minus y into 100 of h square minus ab. Now we are splitting in the form of a plus b into a minus b. By observing that already we have taken the condition of h square minus ab greater than or equals to 0. In this case, just rewriting the terms ax plus, so from these two terms I am taking that y as common, that is y into h plus under root of h square minus ab. Again that from the second bracket also ax plus y into h minus under root of h square minus ab. So by observing these two terms, these two equations in the form in terms of x side y terms only, in these two equations there is no constant term. So therefore, so here in the left hand side, what will be here, sir? So here h equals to ax square plus 2x square plus by square equal to 0. Now here, so comparing on both sides, therefore these two equations are in terms of x and y only. So therefore this equation represents a pair of straight lines. So what are those two equations? Ax plus y into h plus under root of h square minus ab equal to 0, and that ax plus y into h minus under root of h square minus ab equal to 0. These two are in terms of x and y only. Clearly they are passing through the origin. Clearly above two lines are passing through the origin. Now we have proved that so by taking that h square minus ab greater than or equal to 0, that equation represents the pair of straight lines which is passing through the origin. Now let us go for the second case. So in the first case we have taken that a is not equal to 0. Now we are going to take that next case a equal to 0. By substituting that a equal to 0 in the equation ax square plus 2x square plus by square equal to 0 is, that is already a equal to 0 means what? The first term will be 0. Now second term, we have to write the second term onwards. That is 2hxy plus by square equal to 0. From these two terms, we can take that y as common. That is y into 2hx plus by equal to 0. Clearly, so product of these two terms equal to 0 means what? We are equating the both the terms equal to 0. That is y equal to 0 and 2hx plus by equal to 0. Clearly, above two lines are also passing through the origin. So in this case, so by taking that a equal to 0 also, we got that the equation represents the pair of straight lines which is passing through the origin. So therefore, from above two cases, we got that the equation ax square plus 2x square plus by square equal to 0 represents a pair of straight lines which is passing through the origin if and only if h square greater than or equals to ab. So let us discuss about the angle between pair of straight lines. Already we have discussed in the previous chapter. So that is the angle, if theta is the angle between the straight lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c equal to 0, then we have that cos theta equals to modulus of a1 a2 plus b1 b2 by under root of a1 square plus b1 square into under root of a2 square plus b2 square. Here also we are going to get the angle between the pair of straight lines in the form of that ax square plus 2x square plus by square equal to 0. So here let us discuss a theorem, that is, let the equation ax square plus 2x square plus by square equal to 0 represents a pair of straight lines, and that theta is the angle between the given pair of straight lines. Now we have to show that cos theta equals to modulus of a plus b by under root of a minus b whole square plus 4x square. Now let us prove the formula, that is cos theta equals to modulus of a plus b by under root of a minus b whole square plus 4x square. So here, given the equation, let us take that h equals to ax square plus 2hx square plus by square equal to 0. That is represents two straight lines, two individual straight lines. L1 equals to L1x plus M1y equal to 0 and L2 equals to L2x plus M2y equal to 0. Now, if these two straight lines represent the given pair of straight lines, means on now we have to write the combined equation of given two straight lines and we have to equate the given pair of straight lines equation. So already we have done that L1x plus M1y into L2x plus M2y. After simplification, we will have that L1 L2x square plus L1 M2 plus L2 M1 xy plus M1 M2 y square. Now here comparing on both sides. Here, given that this is a pair of straight lines and L1 equal to 0 and L2 equal to 0 are two straight lines and theta is the angle between them. Comparing on both sides. Here L1 L2 equals to A and L1 M2 plus L2 M1 equals to 2H and M1 M2 equals to B. Already given that theta is the angle between the pair of straight lines. Given pair of straight lines means what? Now we have to assume that theta is the angle between the given straight lines, individual straight lines, second and third. Already we have the theorem from the previous chapter, straight lines. So if L1x plus M1y equal to 0 and that L2x plus M2y equal to 0 are two straight lines which are passing through the origin and theta is the angle between them. Already we have discussed in the previous chapter, that is cos theta equals to modulus of L1 L2 plus M1 M2 by under root of L1 square plus M1 square into under root of L2 square plus M2 square is there. So similarly here also to prove above theorem, we have to use the formula cos theta equals to modulus of L1 L2 plus M1 M2 by under root of L1 square plus M1 square into under root of L2 square plus M2 square. So here Now here also we are taking the same lines now. That's why we will get the same thing. So here modulus of L1 L2 plus M1 M2 by under root of L1 square plus M1 square into under root of L2 square plus M2 square. Now here in the denominator we are writing these two terms in the under a single square root symbol. So that is, so again simplifying that. So just see here, in this case, we will have these two terms in the denominator. So what will we do here? We will multiply these two terms. That is L1 square into L2 square plus L1 square into M2 square, and that M1 square into L2 square and M1 square into M2 square. So here, after multiplying these two terms, we will have that is L1 square L2 square. L1 square L2 square means what? We will write it as L1 L2 whole square and L1 M2 whole square plus L2 M1 whole square plus M1 M2 whole square. Now here, in this case, just we have to remember one condition. So in the denominator, so already we have four terms in the previous step. Here we are doing additional work, that is just in this denominator part. In this, inside the square root symbol, just we are adding and subtracting. Here 2 L1 L2 M1 M2, here I am subtracting this term and adding this term, but here these two terms are same in the magnitude. Here just I am rearranging the terms. Here, yeah, as per our convenience, I am writing this first step as 2L1 L2 M1 M2. Again that second step as, so here I am writing 2L1 M1, sorry, 2L1 M2 and L2 M1 like this. So but these two terms are same in the magnitude. Just here I am adding 2L1 L2 and M1 M2, subtracting 2L1 L2 M1 M2. So here now rewriting the terms. So from all these terms, now we are writing the three terms at one place. So that is L1 L2 whole square plus M1 M2 whole square minus 2L1 L2 M1 M2. From these three terms, we will have, these three terms are of the form of a square plus b square minus 2ab. All of you know that expansion a square plus b square minus 2ab, that is a expansion of a minus b whole square, where a is, in place of a is, that is L1 L2, and in place of b is M1 M2, that is L1 L2 minus M1 M2 whole square. From remaining terms, what are remaining terms? L1 M2 whole square plus L2 M1 whole square, again plus 2L1 M2 L2 M1. From these three remaining terms, again these three terms are of the form of a square plus b square plus 2ab. So that are the terms of the expansion of a plus b whole square, that is a square plus b square plus 2ab, that is a plus b whole square, where a, in place of a is L1 M2 and in place of b is L2 M1. So that is nothing but L1 M2 plus L2 M1 whole square. So in this case, we will get that is L1 L2 plus M1 M2 by under root of L1 L2 minus M1 M2 whole square plus L1 M2 plus L2 M1 whole square. So now substituting the values, already we have equated, equating on both sides. We got that L1 L2 value is a and that M1 M2 value is b. So and L1 M2 plus L2 M1 equals to 2h. Now substituting the terms, therefore cos theta equals to we will get that a plus b by a under root of a minus b whole square plus 2h whole square, that is modulus of a plus b by under root of a minus b whole square plus 2h whole square. We can write, after simplifying this one, so that is modulus of a plus b by under root of a minus b whole square plus 2h whole square, that is 2 square is 4, h square is h square only. So therefore we can write this formula as modulus of a plus b by under root of a minus b whole square plus 4a square. We can remember that formula as cos theta equal to this or this one as per our convenience. Here by taking that, so if the pair of straight lines if the angle between the given pair of straight lines is theta equals to 90 degrees, now what will be there? So, if theta equal to 90 degrees, so by substituting in that formula, that is theta equal to 90 degrees means what? Cos 90 equal to 0. From the trigonometry part, we will have the value of cos 90 equal to 0. So equating that cos 90 equal to 0, we will have that modulus of a plus b by under root of a minus b whole square plus 2h whole square, or modulus of a plus b by under root of a minus b whole square plus 4h square equal to 0. Now, in place of cos I am writing that 0. Now here a plus b by modulus of under root of a minus b whole square plus 4h square equal to 0. From the cross multiplication, we will have that modulus of a plus b equal to 0 into under root of a minus b whole square plus 4h square. 0 into something means 0 only. So here modulus of a plus b equal to 0 means what? We will get that a plus b also 0. So therefore we got the condition, if the straight line, if the angle theta equal to 90 degrees, in the given pair of straight lines, we will have the condition a plus b equal to 0. So here a equal to what is that? A is a quotient of x square and b is the quotient of y square. So therefore we got that if h equal to 0, h equal to what is that? Ax square plus 2hx square plus by square equal to 0. That equation represents a pair of perpendicular lines. Then we will have that cos theta equal to 0. Then if cos theta equal to 0, a plus b also 0. So that is nothing but here a is called the quotient of x square and b is called the quotient of y square in the given equation, ax square plus 2h square plus by square to 0. So let us solve some problems. Find the angle between the pair of straight lines. So here 2x square minus 3xy minus 6y square equal to 0. So first of all, we have to compare the given equation with the pair of straight lines. Ax square plus 2h square plus by square equal to 0. So here a equals to 2 and 2h equals to minus 3 and b equal to 6. Now substituting that a, 2h and b values in the cos theta formula, we have that cos theta equals to modulus of a plus b by root of a minus b whole square plus 4h square. This 4h square nothing but 2h whole square. Now substituting the values. So therefore here a plus b, modulus of a plus b, modulus of 2 minus 6, modulus of 2 minus 6 by under root of a minus b whole square. 2 minus or minus 2 plus 6 whole square plus here already we know that 4h square can be written as that is a square of the 2h. So we can write directly that is minus 3 whole square. This is 4h square part. Minus 3 whole square. After simplification, we will have that is modulus of 2 minus 6 equals to modulus of minus 4. 2 plus 6 is 8. 8 square plus minus 3 whole square equals to 9. So after simplifying that, we will have that 4 by under root of 64 plus 9. So after simplification, so for here 4 by root 73. So we will get that cos theta equals to 4 by root 73. From the concept of our inverse trigonometric functions, from the our trigonometry part in our first year only. So if cos theta equal to k, we will have the result of theta equal to cos inverse of k. So here also it is in the form of cos theta equals to 4 by root 73. Therefore, we can write that theta equals to cos inverse of 4 by root 73. Therefore, the angle between the given pair of straight lines 2x square minus 3xy minus 6y square equal to 0 is how much? Theta equals to cos inverse of 4 by root 73. Here also one more problem we have to discuss, that is here does the equation x square plus xy plus y square equal to 0 represent a pair of straight lines? So first of all, by observing that equation as x square plus xy plus y square equal to 0, it seems to be ax square, of the form of ax square plus 2hxy plus by square equal to 0. We have to check whether this equation represents the pair of straight lines or not. So all the equations of the form of x square plus x square plus 2h square plus b square equal to, that is, so this type of equations may not represent the pair of straight lines. Let us check whether this equation represents the pair of straight lines or not. So given equation is x square plus xy plus y square equal to 0. So here also we have to compare the equation x square plus xy plus y square equal to 0 with the equation ax square plus 2h square plus by square equal to 0. So therefore here a equal to 1 and the 2h equals to 1, b also 1. So we got the values of a equal to 1, 2h equals to 1 and b equals to 1. So here already from the previous theorem, we have concluded that the condition that to represent the pair of straight lines is, what is that, sir? H square minus AB greater than equal to 0. That is, H square must be greater than equals to AB. So here, so first of all, we have to find out the value of H square minus AB value. H square, here 2H equals to 1 means what? H equals to 1 by 2. H square minus A equal to 1, B equal to 1. AB, 1 into 1. So here 1 by 4, that is 1 by 2 whole square is 1 by 4 minus 1. Here we will get that 1 minus 4 by 4. Nothing but minus 3 by 4, which is less than 0. But as per our condition, this must be h square greater than or equals to AB. So here h square minus AB must be equal to 0 or greater than 0. It must not be less than 0. Then only the given equation represents a pair of straight lines. So here in this case, we got the condition that h square minus AB is less than 0. So therefore that the given equation does not represent the pair of straight lines. So let us solve one more problem, that is find the acute angle between the pair of straight lines represented by the equation x square minus 7xy plus y 12y square equal to 0. So given equation is x square minus 7xy plus 12y square equal to 0. Here also comparing the above equation with that ax square plus 2h square plus by square equal to 0. Here a equal to 1 and that 2h equals to minus 7, b equals to 12. Already we know that theta is the acute angle between the pair of straight lines. So we have that cos theta equals to modulus of a plus b by root of a minus b whole square plus 4a square. So here we will get that substituting the values a equals to 1 and 2h equals to minus 7, b equals to 12 in this cos theta formula. We will have that modulus of 1 plus 12 by under of 1 minus 12 whole square plus minus 7 whole square. So here 1 plus 12 is 13, that is modulus of 13 by under of 121 plus 49. So after simplification 13 by root 70, 170. So here we got that cos theta equal to 13 by root 170. Here theta equals to cos inverse of 13 by root 170. So here, so students, so try these problems. So find the acute angle between the pair of straight lines represented by the equation x square minus 4xy plus y square equal to 0. Second problem is find the acute angle between the pair of straight lines represented by the equation y square minus xy minus 6x square equal to 0. Prove that the equation 2x square plus 3xy minus 2y square equal to 0 represent a pair of perpendicular lines. So in this case, these two problems are solved by taking that cos theta formula. Here, first of all, we have to compare the given equations with the ax square plus 2x square plus b square equal to 0, and we have to use that formula cos theta equals to modulus of a plus b by under of a minus b whole square plus 4a square. Now here, prove that the equation 2x square plus 3xy minus 2y square equal to 0 represent a pair of perpendicular lines. So what is the condition? So already we have discussed that if the equation ax square plus 2h square plus by square equal to 0, to represent the equation pair of perpendicular lines. Already we got that x square quotient plus y square quotient equal to 0. So here also you have to check whether the equation represents the pair of perpendicular lines or not. So now we have discussed that in this session today we have discussed that combined equation of two straight lines, that second degree homogeneous equation, second degree general equation in x and y. The equation h equals to ax square plus 2h square plus by square equal to 0 represents a pair of straight lines passing the origin if and only if a square greater than or equals to ab and angle between the pair of straight lines. So here combined equation of two straight lines. Already by taking that L1 equal to 0 and L2 equal to 0, we have written the equation of the combined equation of those two straight lines of the form of L1 into L2 equal to 0. That is of the form of Ax. We have obtained that the second degree homogeneous equation is of the form of Ax s equal to 0. That is s equal to ax square plus 2x square plus by square plus 2. Homogeneous means what? Only we will have three terms. Ax square plus 2x square plus by square equal to 0. Next to second degree general equation in x and y terms. So here, so this can be denoted as h equal to 0, and that this third one is second degree general equation in x and y is, that is s equal to 0. That is s equal to ax square plus 2h square plus by square plus 2gx plus 2fy plus c equal to 0. So what is the difference between these two equations? So in this equation that 2gx term and 2f. So here now the equation, we have proved that the equation h equals to ax square plus 2h square plus by square equal to 0 represents a pair of straight lines passing through the origin if and only if h square greater than or equal to ab. So in this case we have taken that. So by taking that, this equation represents the pair of straight lines passing through the origin. We have proved the condition x square greater than or equals to ab, and again in the converse part we have taken that condition x square greater than or equals to ab, and we have proved that this equation represents the pair of straight lines. So at last we have derived the formula for the angle between the pair of straight lines. And the condition of pair of straight lines to be perpendicular.
Thank you, Srinivas Garu. Students, you must have understood the combined equation of pair of straight lines, which is homogeneous, is of the form ax square plus 2hxy plus by square is equal to 0. And also the general form of the second degree equation in x and y, which has an x term, a y term, and a constant apart from the homogeneous equation along with. That means ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 also represents a pair of straight lines. So, sir has also explained you about the condition for the homogeneous equation to represent a straight pair of straight lines, which is a converse condition, if and only if a condition. And sir has also explained you about the angle between the pair of lines, which is cos theta. Formula is given. Finally, the condition for the straight lines to be perpendicular to each other, that is a plus b must be equal to 0. I'm sure what the questions that sir has given you are of each one model. But you can visit your textbook, you can take the questions from the exercise and solve those problems. You can also revisit the same session in order to clarify whatever doubts you have. Thank you, Srinivas Garu, for a wonderful explanation. There was a technical issue, connectivity issue for few seconds here and there, but that is okay, which is not in our hands. Thank you so much, sir.
Thank you, madam. Thank you. Thank you, madam. Thank you very much.